Continuing on with review for the midterm in PUH 250. Remember, everything begins with a question. I wonder if age is related to blood pressure. Is blood pressure different by gender? Will a new medication lower blood pressure compared to a standard medication? Generally boils down to if this variable is related to that variable. Does this variable predict that variable? Is this variable different by the other variable? And this is your research question. Once you've designed and specified your research question, you can designate an outcome, Y, and a predictor, X. To answer your question, you need data. Remember, data is how biostatistics gives us evidence for public health. To review data types, ask yourself, can you get a mean from this variable? Is it in categories? And if it's in categories, how many groups are there? Consider gender. This is a categorical variable. You would report the N in percent with each gender. Consider age. Age could be a number. If it was symmetric, you'd report a mean standard deviation. If age is skewed, you'd report a median IQR or a median min-max. Age could also be collected categorically in groups, which would be an ordinal categorical variable, and in that case, you'd report N in percent. Race is a categorical nominal variable, and you would report N in percent. Variables like weight and income can be both. Like age, weight and income could be a number or it could be collected in categories. In addition, weight could also be combined with height to create the body mass index value. And then BMI could actually be a number or category. Income is similar to weight in that you could collect a specific number, but often people don't know that, and generally income is collected in categories. In any case, remember, if you can collect data as a number, do so. You can create categories later. So once you've specified your research question and you've collected your data, you would begin by summarizing your data. These types of variables are often called demographics or sociodemographics. You would also summarize your outcome variables. And then you would move on from this, which is univariate analysis, to addressing your question of interest. In JUMP, to do your univariate analysis, you use analyze and distribution. And you can see here for the variables race, gender, age at baseline or at the start of a study, weight, and BMI at baseline, you get your distributions from JUMP. For race and gender, you'd want to use N in percent because they are categorical variables. Remember, JUMP gives you a probability, so JUMP gives you a value from 0 to 1. You multiply that by 100 to get your percentage. For age, weight, and BMI, you must first look at the distribution. For age, it is rather symmetric, meaning that from the center point, you have roughly equal amounts of data to the left and to the right, and it forms a general mound shape or bell shape. In age case, you want to use mean and standard deviation as it is rather symmetric. In looking at BMI, it is rather skewed, meaning that we have a shift in the tails or the ends of the distribution. They are more on one end than on the other. And in this case, you'd want to use a median with an interquartile range or the median with the minimum and the maximum. This is for skewed distributions. Sometimes you need to create new variables from the data that was collected. And in this case, you'll use a recode option or a formula. When looking at this particular race value, it is predominantly Caucasian, with only 7% African Americans and 5% others. To do meaningful analysis, you may want to combine all of the other races into a single category. In this case, other would stay other, and African American would also become other. So you would end up with race in two groups from the recode option in JUMP. For age, you may have questions regarding age, people being over or under the age of 40. So less than 40 or 40 plus. Because there are so many options for age, doing a recode would be very difficult and time consuming, and in this case, you would want to use a formula. This is a relatively straightforward formula and only creates two groups from age. So age was collected as a continuous numeric variable, and in this case, dichotomized for people who are 40 or older and those who are younger than 40 years of age. How you will use the variables and how you will create or recreate new variables depends upon your question at hand, which is why it is so imperative that your research questions are well defined. So now that you've done your univariate analysis, what about answering your question for a bivariate analysis? That's where fit y by x comes in. And this is to get the evidence to answer your question. You're going to fit an analysis. We have three bivariate analyses to consider: a contingency analysis, group means, or correlation. And again, this is fit y by x in JUMP. Beginning with a contingency table, the question is the percentage of y different by the x groups? Both variables in this case are categorical. You are comparing the percentage with each level of x that have the outcome of interest in y. You get a contingency table or a 2 by 2 table in this example because gender has 2 levels and whether or not someone has health insurance has 2 levels. We want to use row percents to report the n in percent of each row that has the outcome of interest. For this example, you would want to say that of females, 89.8% of them have health insurance, and of males, 85.9% of males have health insurance. For group means, the question is the mean of y different by the levels of x? And in this case, you have a continuous y and a categorical x, and you're comparing the mean of y by x level. Your output has your categories on your x-axis, so again, health insurance, yes and no, and your age on your y-axis. And the question here is the mean age different by whether or not people have health insurance? So do those with health insurance have a different mean age compared to those without health insurance? Here you can see the means and standard deviations, and it's roughly similar. We have those without health insurance have a mean age of 40.6 with a standard deviation of 10.5, and those with health insurance have a mean of 40.7 with a standard deviation of 9.7 years of age. Or you can ask for quantiles and report the median with the IQR or the median with the range, depending upon how the distribution of your age looks. In our case, we know that age was relatively symmetric, and so we would report the mean and standard deviations. Our final bivariate analysis is correlation. The question here is, are x and y related? Both variables in this case are continuous, and we'll be looking at correlation. Is it positive or negative, and how strong is the correlation? This is answering the question about whether or not x and y are related. When you do this in JUMP, you get a bivariate fit, and in this case we have BMI by weight. Weight on the x-axis and BMI on the y-axis, and you can see from the picture, called a scatter plot, that in general it looks as if weight increases, then BMI also increases, which is a true relationship that we know to exist. With correlation, you want to report the strength and direction of correlation and the mean and standard deviation of each variable, which you should have already determined based upon your univariate analyses. So you would report here that the average weight in pounds was 180.5 pounds with a standard deviation of 44.6 pounds, and the mean BMI was 28.6, putting them in the obese category of BMI with a standard deviation of 6.7 on the BMI scale. In this case, it is a strong positive relationship with a correlation of 0.89, meaning that as weight increases, BMI increases, and they are rather highly related. You would also, for all three of these questions, want to report the total N as well as the N per group if you're looking at contingency tables and group means. When you report data from a bivariate analysis, make sure to include your question. Include a summary of each variable that you'll be considering. Remember, you need to describe the sample, so it's not just the two variables in your bivariate analysis, but also who are the people or the units of observation that this represents the population. So include if you need to recode or create a formula. So for example, while you may report the mean age, overall, you would also want to say for analysis, age was grouped as 40 plus versus less than 40 years of age. Include a summary of your bivariate analysis, including any of your applicable statistical summary results, and state your conclusion. It's important that throughout your report you use real words and not variable names. Basically, tell the story. Start with the question, describe your data, present your analysis, and state your conclusion. Using data sampled from a population, biostatistics provides evidence for associations between variables, looking at contingency tables, group means, or correlation. You could look at changes over time. So how does blood pressure change over time? You could look at impacted groups and populations. Is blood pressure different by racial group? And you could use that evidence to target resources. If you find differences, are there interventions that could alleviate those differences and make for more equal results across populations that are at risk? Biostatistics can help you tell a story with data. Be clear, be concise, be methodical, and always remember to answer your question.